Hello, hi everyone. Welcome to Restoring the Brand. So today topic is electric current. Electric current, CBSE grade 10 physics. So electric current is nothing but the rate of flow of charge is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. Okay. So now we will discuss about the rate of flow of charge. I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So here you can observe. I equal to Q by T. SI unit of current is ampere. So SI unit of charge is coulomb. SI unit of time is second. Okay. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current, right? Now, so 1 coulomb is nothing but in 1 coulomb, that is nothing but Q. So number of electrons. So if you are taking the conductor, see inside of the conductor there are many electrons are flowing. If only one electron is flowing, we can't say current is flowing. Only two electrons flows, we can't say current is flowing. There are many. Okay, that's why Q equal to Ne. Q equal to Ne, right? So that's why. So I'm taking Q equal to Ne. N equal. So Ne is the number of charges. Okay, number of. So integral multiple. There are many charges are moving in the conductor. So that's why we are saying integral multiple. Integral multiple. So Q equal to Ne. Okay, on one electron, 1.6 into 10 power minus 19 coulomb. 10 power minus 19 coulomb. In 1 coulomb, so in 1 coulomb, how many electrons are present? We will see. So in 1 coulomb, 1 Q equal to 1 by 1.6 into 10 power minus 19. That is nothing but, so 1 by 1.6 into 10 power 19. That is nothing but 0.625 into 10 power 18 electrons. Okay, 0.625. We can say 0.625 into 10 power 18 electrons. So 10 power 19 only. Okay, 10 power 19. 10 power 19. Okay, but so after removing 1 0, so we'll get it. So 10 power 19. In 1 coulomb, so 6.25 into 10 power 18 electrons are present. Okay, in 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so that's enough. These 2 points are very important. On 1 electron, how much charge is present? In 1 coulomb, how many electrons are present? How many electrons are present? So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So the rate of flow of charge is called electric current. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. Q equal to Ne. On 1 electron, 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, 0.625 into 10 power 19 electrons. Then you will get, so 1 coulomb 6.25 into 10 power 18 electrons are present. Okay, so this is about current. Now we'll discuss about electrical elements. Okay, so then we will discuss about electric circuit, everything. Let's start. So now first one is cell. This is cell, positive terminal, negative terminal. Second one is battery. Battery. So positive terminal, negative terminal. Third one is, so this is open switch. Open switch. And next one is closure switch. Closure switch. This is a closure switch. And fifth one. So you can see here cell, the battery, open switch, closed switch, resistor, rheostat. So wire joining, wire crossing, this wire joining, this wire crossing, and this the bulb. This is the bulb. So here you can see resistor. Resistor is a device which is used to oppose the electric current in the circuit. Rheostat is the device which is used to regulate the current without changing the voltage source. So rheostat is the device which is used to regulate the current without changing the voltage source. So this is wire joining, wire crossing, and this one is the bulb. Okay, so now we will discuss about electric circuit. Electric circuit. Electric circuit. Electric circuit is electric electric circuit. Okay. So ammeter, voltmeter also there. So ammeter, voltmeter. So a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric circuit is known as an electric current is known as an electric circuit. Here positive charges are moving from positive terminal to negative terminal. whereas electrons are moving from negative terminal to positive terminal. Okay, so here you can observe conventional current, conventional current, and the second one is electric current, electric current. So conventional current is nothing but the flow of positive charges is known as conventional current. Electric current is nothing but the flow of negative charges, that is nothing but electrons. So conventional current, electrons, so positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Okay, so this is about conventional current and electric current. Conventional current is nothing but, so charges are moving from high potential to low potential. So charges are moving from high potential to low potential, whereas electrons, so charges are moving from low potential to high potential. So electrons are moving from low potential to high potential. So conventional current is nothing but positive charges are moving from, so positive terminal to negative terminal. So a continuous and closed path of an electric current is known as an electric circuit. Okay, so that is about electric circuit. Now we'll discuss about conventional current and electric current. So already over. Conventional current is nothing but flow of positive charges. Electric current is nothing but flow of negative charges. Now, so we'll discuss about electrical potential difference and electrical potential. Potential difference. Potential difference. Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point and within the conductor is called potential difference. Okay, so you can observe here. So we are doing some work to bring unit positive charge. So this is a positive charge. We are doing some work to bring unit positive charge from point A to point B. So that is nothing but electrical potential. So V equal to W by Q. W, that is a potential difference. So coming to electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So I am taking this infinity. So positive charge, we are doing some work. So this is the field. We are doing some work to bring unit positive charge from infinity to the required field is called electrical potential. V equal to W by Q. So V equal to W by Q. So here you can observe, in this case, potential difference. Potential difference means, so work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. V equal to W by Q. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential, right? Yes. So now we'll discuss about Ohm's law. So Ohm's law is nothing but potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Okay. So now materials required. Materials required. First one is 4 cells. 4 cells of 0.5 volts each. Second one, nichrome wire is an Li of nichrome wire coming to switch coming to bat switch. Cells already completed. Ammeter, voltmeter, and connecting wires. So 4 cells, 1.5 volts each. So nichrome wire, switch, ammeter, voltmeter, connecting wire. So circuit diagram I'll draw here. So here you can see. So now procedure to do. Okay. First connect one cell and note down the reading of ammeter and voltmeter, and connect two cells. Connect two cells and note down the reading of ammeter and voltmeter. 4. Okay, so Ohm's law at constant temperature, the potential difference. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. And even the physical conditions also same. We can observe, so metals required 4 cells, 1.5 volts each. Okay, so we can take, so 4 cells we can consider, 4 cells, 4 cells we have to take. Okay, so that is 0.5 actually, and 1 meter. Okay, so nichrome wire, so switch, ammeter, voltmeter, so connecting wires. So procedure, first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. So this is a circuit diagram. Okay, so now we can see, so draw the graph. So after observing the values, you have to mention in the tabular form given below. So you have to mention here. Serial number, number of cells, so current, voltmeter V by I equal to R. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. So you have to check. So connect one cell and note down the reading of ammeter and voltmeter. Ammeter means current, voltmeter means potential difference. Okay, and next connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and mention in the tabular form in the given below. Next one, so you have to draw the graph for VI. VI graph gives straight line. VI graph gives straight line. So I am taking like this. So V on y axis, I on x axis. Okay, the graph is straight line. Okay, so it obey Ohm's law. Ohm's law is nothing but at constant temperature. Okay, so the conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So once again, check here. So you can observe first, Ohm's law is nothing but Ohm's law. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay. So metals required 4 cells, nichrome wire, switch, ammeter, voltmeter, connecting wires. So here you can observe 4 cells, 1, 2, 3, 4, ammeter, voltmeter, a resistor, switch. So first you have to connect one cell and note down the reading of ammeter and voltmeter. So that is nothing but current. And so next connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 mentioned in the tabular form, and draw the graph for VI. VI graph gives a straight line. VI graph gives straight line. So the conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So next one, so we'll discuss about resistor and resistance. Resistor and resistance will discuss. Resistor and resistance. Resistor and resistance. Resistance and resistivity. Resistor only the resistance is nothing but phenomena. Resistance and resistivity. Resistivity. Okay. So R is directly proportional to length of the conductor. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So here rho equal to RA by L. Rho equal to RA by L. Okay. So now we can observe here. So resistivity equal to SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So rho equal to ohm meter. And here resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. Okay. So now, so resistance depends on temperature, and resistance depends on material of the conductor. Material. Here also resistivity depends on temperature, and resistivity depends on material of the conductor. Okay, so you can observe here once again. So resistance is the phenomenon of opposing the electric current circuit. R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. So resistance depends on temperature. Resistance depends on material of the conductor. Here resistivity. So resistivity is equal to resistance of the conductor per unit length and unit cross section area. So here SI unit of resistivity is very important, ohm meter. SI unit of resistivity. So resistivity depends on temperature. Resistivity depends on material of the conductor. So now we will discuss about so resistor connected in series combination. So here you can observe resistors are connected in series combination. Here is R1, R2 and R3. So resistors are connected in series combination. Okay. So then current is same throughout the circuit. So Is equal to I1 equal to I2 equal to I3. So throughout the circuit current is same. Then so from Ohm's law V equal to IR, I now so Vs equal to V1 plus V2 plus V3. So IRS equal to so this is a formula. Resistors are connected in series combination. If n number of resistors are connected in series combination, so Rs equal to Nr. So now we will discuss about resistors are connected in parallel combination. So check once. So potential difference across three resistors the same. So P equal to V1 equal to V2 equal to V3 equal to V. So current is different from Ohm's law. V equal to IR, I equal to V by R. Okay, then so we can substitute. So IP equal to I2 plus I3, that is V by RP equal to V by R1 plus V by R2 plus V by R3. So here I am taking V common. So if I take V common, then we'll get 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V get cancelled. So the remaining value is 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. If n number of resistors are connected in parallel combination, so 1 by Rp equal to N by R, Rp equal to R by N. So if n number of resistors are connected in parallel combination, that's the formula. Check once here. Here. Okay. So I hope it is very clear. Just check once. Resistors are connected in series combination, and actually this is a parallel combination. Series combination before only it is completed. Just before we have finished. This is a parallel combination. Okay. So next we will discuss about heating effect of electric current. Heating effect of electric current. So V equal to W by Q, W equal to VQ. So P equal to W by Q, W by T. So the rate of doing work is called power. So VQ by T, P equal to, so V into Q by T, that is nothing but I. So current. Then we can say, so E equal to P into T, that is Vi into T. So H equal to V into I into T, V equal to IR, V equal to IR. So H equal to IR into I into T. Then heat produced in the conductor is directly proportional to I square RT. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. I hope it is very clear. So this is about heating effect of electric current. Okay. So very important formulas. So make sure that you are practicing. If you like the content, if you like the explanation, do like, share and subscribe to Student the Brand. So thank you so much for joining and attending and listening my class.